Hi guys, it's Mrs. Allison. Today we are going to finish up our radical unit by looking at graphing radical functions, both square root and cube root. And to do that, we are going to begin by looking at their parent functions. Each of the graphs that we're going to look at are going to be based on these parent functions, just like we did with quadratics, just like we did with absolute value. These parent functions become the basis of everything that we're going to do with these graphs. So let's get started. Let's start with the square root. Now, you'll notice when we graph the square root of x, f of x equals the square root of x is the parent function, or y equals the square root of x. You'll notice that the table of values that I'm giving you now is kind of weird. If you look at the x values that I've given you, I haven't given you all of the x values, but let's talk about why. Let's think about the domain of the square root function, and we've talked about this several times. What do we know about the domain of the square root function? Well, we know we can't have negatives underneath the radical, right? We can't take the square root of a negative number. So my domain is either x is greater than or equal to 0 in inequality notation, or in interval notation, I may say it goes from 0 to infinity. I can plug in as big of a positive number as I want. I just cannot plug in a negative number. You'll also notice that on my table of values, I don't count consistently. Why do you think that is? I know these numbers here, 0, 1, 4, and 9, are perfect squares. So I know I can find the square root of them. Whereas, say, for example, 2, I don't know the square root of 2. So it would be a lot trickier to graph because I don't know that square root. So if I look at these, the square root of 0, we know to be 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. Remember, when we have these, we are just plugging this number 4 into this function, the square root of x. So the square root of 4 is 2. And now if I plot this graph, you'll see 0, 0, 1, 1, 4, 2, 9, 3. And if I sketch this, you can see it looks like a parabola that has been turned on its side, or half of a parabola that's been turned on its side. So there's my square root function. That's my parent function. Now, most of the time on this, we will actually just sketch these first 3 points right in here. We will usually just graph those 3. That doesn't mean you have to only graph those 3, but that's typically what we do when we graph them. For the parent function, I don't really need 4 points necessarily, but I wanted you to see the picture of this and see what this graph looks like. Now, does the picture of the graph match what we said our domain should be? Yeah, it does. It's all the x values that are greater than or equal to 0. Now, what about my range? Remember, range is the possible y values. And if I look at this graph, I can see that y also is greater than or equal to 0. Or if I want to write it in interval notation, it is 0 to positive infinity. It's all of the positive y's. I can get 0, I can get 1, I can get 2, I can get 3. I will eventually get up here. It's going to take me a long time, but I will eventually get to all of those y values. So my domain is x is greater than or equal to 0. My range is y is greater than or equal to 0. So this is the parent function of the square root of x. Keep that in mind because when we start to make our transformations, we're going to use that. All right, let's move on to cube root. You'll notice again with the cube root, I have weird values in my x that I've given you. And you'll notice I've included negatives. Why can I do that? Why can I include negatives with a cube root? Well, because I can take a cube root of a negative, I just can't take a square root of a negative. So thinking about our domain of a cube root, is there anything that we can't plug into the cube root? No, there's nothing we can't plug in. So my domain is going to be all reals. You could write it with that little double r, or you could write it with the interval notation would say negative infinity to infinity. And remember, infinity we put parentheses, not brackets, like here, because we can never contain infinity. We can't actually get to the number infinity. All right, so let's make substitutions. Let's take each of our x values and substitute them into our cube root function. So if I do the cube root of negative 8, we get negative 2. If I do the cube root of negative 1, we get negative 1. If I do the cube root of 0, we get 0. Cube root of 1 is 1, and the cube root of 8 is 2. So now when I sketch a graph of this, you can see, whoops, negative 8, negative 2, positive 8, positive 2. We've got this cubic function, almost, like a cubic function turned on its side, or rotated a little bit. So this is my cube root graph. Now what about my range? If we think about our range looking at this, is there any y value that I won't get to? No, I'll be able to get to all my y values. So my range here is also all reals. That makes the cube root really nice because the domain and range is always going to be all reals. So negative infinity to positive infinity, if we want to do it in interval notation. So these two are our parent functions. So really, when you're graphing radicals, you need to ask yourself, well, what kind of radical do I have? Do I have a square root or do I have a cube root? Those are the only two radicals we are going to focus on this year, graphing-wise, square roots and cube roots. Now, along with the idea of parent functions, we cannot forget our function transformations. Remember, each of our parent functions show us what transformations are happening just by the way they're written in the equation form. So if we have y equals a times the square root of x minus h in this square root, plus k outside, or y equals a times the cube root of x minus h in the cube root, plus k, we know that there's several transformations that happen. Remember that our a value will stretch my graph if a is greater than 1, or shrink it if it's between 0 and 1. Or if a is negative, remember it's a flip, it's a reflection. We said flip sometimes, that's fine too, flip, reflect. Remember that if h is greater than 0, now let's talk a little bit about h, and I want you to make a note on this with the h, and I want you to make the note that this is how it looks in the equation. I didn't leave myself enough room to write that. Because if it looks like h is greater than 0 in the equation, then it's actually moving left. Why is that? Well, that's because the equations should say x minus h. So if it appears like it says x plus 2, really what's happening is I'm doing x minus negative 2. So really the h is negative. It just appears positive in the equation. So I want you to make note that this is how it looks in the equation. That's important. So if h looks positive, if it looks like it's greater than 0, it's moving left. And if h looks negative, then it's actually moving right. And k in the equation is just how it looks. If it's greater than 0, it's moving up. If it's less than 0, it's moving down. So remember, this equation with that negative in there is a little bit tricky when we talk about moving left and moving right. Okay. Okay. So your first step when we're going to graph these is to, 1, determine are we graphing a square root or a cube root? Once we determine what we're graphing, then we're going to use our function transformations and the parent function that we know. So keep those parent functions visible so you can make a quick sketch. Let's look at some examples. So the first thing I'm going to look for is whether this is a square root or a cube root. So in this first graph, y equals the square root of x minus 5, I notice that the index is not there, which means it's 2, meaning it's a square root. Okay. knowing it's a square root, it might help you to graph the parent function on your axes. And I know the parent function is at 0, 0, 1, 1, 4, 2, and 9, 3. If you want to go that far, I'm okay if you just graph those 3 points, those first 3. So remember, the parent function, we're utilizing the parent function that's up here, and I'm utilizing these 3 points, 0, 0, 1, 1, 4, 2. So I just have those sketched in there. The next thing I'm going to do, so I know that's my parent function, the next thing I'm going to do is I'm going to look at what transformation is happening. And what I see is that I have a -5 outside of the square root, which means that this is shifting down 5. So I'm going to take each of my parent function points and I'm going to shift them down 5. So instead of the ordered pair 0, 0, I'm now going to have the ordered pair 0, -5. Instead of 1, 1, I'm now going to have 1, -4. Instead of 4, 2, I'm now going to have 4, go down 5, sorry, 4, -3. And now my graph is going to be the exact same shape as it would have been up above. It's just shifted down 5 units. So let's talk about my domain. My domain on this one still only has x values that are greater than or equal to 0. So I'm still just going to say x is greater than or equal to 0. Then my range has changed. The smallest y value I can get now is not 0, but -5. So I can get -5 on up. Sure, it's going to take me a while to get up to say 10, 20, 40, but my lowest is -5. So the lowest I can start is -5. You can either write this as y is greater than or equal to -5, or in interval notation, -5 to infinity. So what you'll notice is shifting it up and down changes my range for this square root function. All right, let's look at the next one. Again, the first thing I want to ask myself is it a square root or a cube root? Because that definitely changes how I graph. And what I notice on this one is reading this equation, I've got f of x equals the cube root of x minus 1. So this is a cube root. So I've got to keep in mind that the parent function I'm using, so let's sketch that parent function just so I can get it on my graph. The parent function I'm using is 0, 0, 1, 1, 8, 2, -1, -1, and -8, -2. So my parent function is that cube root function that we graphed up above. Remember, all of this is the parent function that I'm using. Oops. Right in here. Okay. So now I'm going to make a decision based on what transformations I have as to how to graph the rest of this. And what I see is that this has a -1 inside of the radical, which means because it looks like it's a -1, I'm going to move the graph to the right 1. So I'm going to take each of my points and shift them to the right 1, keeping their y values the same, and changing all of their x values. So there's the sketch of my cube root of x minus 1. Now what's my domain and range? Remember, this is a cube root. Cube root has the nice domain and range. Domain, all reals. There's nothing I can't plug in. I can plug in negative numbers, decimals, fractions. I can plug it all in. My range, also all reals. It is possible to get to every possible y on this graph. Sure, some of these y's are going to take a long time to get to, but I can get to them eventually. So that's using function transformations for square root and cube root. Let's look at a couple more. If you're feeling brave, hit pause and try a couple of these and see how you do. Okay, the first thing I'm going to look for. The first thing I'm going to look for on any of these graphs is whether I'm dealing with a square root or cube root. So this says graph y equals 2 square root of x plus 4 minus 1. So this is a square root. The next thing that I will probably do is sketch my parent function, because I know all of my transformations come from my parent function. So there's my 3 parent function points that I'm concerned with for square root. Now I'm going to dissect what changes need to happen. And what I see here with an a value of 2, I'm going to stretch my graph by a factor of 2. And remember, that's the first thing I'm actually going to do. So the first thing I would do is stretch my graph. Remember, stretching by a factor of 2 means multiplying only the y values by 2. And that's before you do any other transformations. So let me just write that. Before other transform. Okay, so I'm going to stretch it by a factor of 2. This plus 4 in here tells me I'm moving to the left 4. And the minus 1 here tells me I'm moving down 1. And remember, I can do the left 4 down 1 once I've done this stretch by 2. Okay, so let's take it in steps. I'm going to graph the stretch by 2 in green first, just so we can do a different color. Multiplying all my y values by 2, my stretch by 2 would look like this. So I've changed each of my y values. 0 by 2 is just 0. 1 by 2 is 2. 2 by 2 is 4. And so here are my y values. Now I need to take each of those points and move them left 4 and down 1. So I'm going to go left 4, down 1. Left 4, 3, 4, down 1. Left 1, 2, 3, 4, down 1. And my graph looks like this. So there is my graph. Now let's talk domain and range. Notice that my graph moved left 4. So what was once x needed to be greater than or equal to 0, now is going to be x needs to be greater than or equal to negative 4. X needs to be greater than or equal to negative 4. Or if you want to use interval notation, we would say negative 4 to infinity. And I don't care which one you use. I'm just doing it in a different color so you can see it. My range, well, my range value, notice I shifted down 1. So what used to be greater than or equal to 0 is now going to be greater than or equal to negative 1. So we could write y is greater than or equal to negative 1, or in interval notation, we'd go negative 1 to infinity. How'd you do on that one? All right, let's keep going. Remember, again, I'm checking to make sure if I'm dealing with square root or cube root. So when this says graph f of x equals negative cube root, important, of x plus 2, with that plus 2 outside, I'm going to first sketch my parent function. I'm a visual person. I like to have my parent function on my graph. Sometimes it definitely can get a little bit messier when you have all these graphs going at one time. Colors help with that, I think. Now, the first thing that I see on here, based on the transformations that are happening, is I see this first step says to flip. Now, I know I want to do this one first, do this before any other transformations, just like I did the a value on the last problem. So I'm going to deal with that first. So I'm just going to flip all of my y values. What was positive is now negative. What was negative is now positive. So this graph is just going in the opposite direction now. Oops, that one didn't go down far enough. Back, put that at negative 2. And there's my green. The green is the new graph. Now, the next part tells me that I am going to, since this is outside of the cube root, I'm going to shift it up 2. So I'm going to take each of my new points and I'm going to shift them up 2. So I'm shifting everything up 2. And then I can sketch my graph because I don't have any left or right. And there's my cube root function. Domain and range. Remember, it's cube root, so this is easy. All reals, all reals. In fact, if you want to write all reals as soon as you see a cube root before you even graph it, that's fine. Okay, so if you didn't quite get those or were uncomfortable with the idea of sketching them, try hitting pause now and see if you can get these last two. All right, looking at these last two again, check to make sure whether you're dealing with square roots or cube roots. That's important. This first one is a square root. And so I'm going to sketch my square root graph, my parent function, 0, 0, 1, 1, 4, 2. That's what it would look like. Now I'm going to think about the transformations that I'm given. Let's see. I'm given a flip. I'm given a shrink by a half, which means that each of my y values are now going to be multiplied by a half. Now let's look at both of those. Those we can do together because they're both part of the a value. So I'm going to flip and divide by a half. 0 is not going to change, but my first point is not going to be 1, negative 1. It's going to be 1, negative a half. And my next point is going to be 4, and instead of 2, negative 2, it's going to be 4, negative 1. So here's my flip in my half in green. And then this blue part says that what I'm going to do now is shift it to the left 1. Okay, so I'm going to take each of my values and go left 1, left 1, left 1. Okay, domain and range on this one is going to be the most important. Let's talk domain first. My graph has shifted to the left 1. Therefore, my domain is that x needs to be greater than or equal to negative 1. Or in interval notation, negative 1 to infinity. I do not care which one you use. Let's talk range though. Range remembers the possible y values. And what I know is that because this was flipped, the highest y value I can get, the highest is 0. Meaning I'm dealing with all the numbers below 0 because of how it was flipped. So my range here would be actually y is less than or equal to 0, or in interval notation would start at negative infinity and the highest it could go is 0. So my range is a little bit weird because of that flip with the square root. All right, let's try the last one. Again, I'm going to first look to see whether it's a square root, cube root. This is 2 times the cube root of x plus 1. I really like that plus 1. I think I've done it multiple times today. X plus 1 minus 2. Okay, so it's a cube root function. I'm going to sketch that parent function. 0, 0. I've got negative 1, negative 1, positive 1, positive 1, positive 8, 2, negative 8, negative 2. And here's my graph. Looks like that. There's my parent function. Now I'm going to go decipher what all of these things mean. I've got to stretch by 2. So stretch by 2 I'm going to do first. I'm going to take each of the y values and multiply them by 2. 0 won't change. 1 will become 2. 2 will become 4. Negative 1 will become negative 2. Negative 2 will become negative 4. So this is what it would look like if that's all I had. But then, inside here says I'm going to go left 1, and I'm going to go down 2. Remember, you can do the left and down or the right and up or whatever combination. The left, right, up, and down together. So now I'm going to go left 1, down 2. Left 1, down 2. Left 1, down 2. So I'm just moving each of my points left 1, down 2. And then I'm going to sketch my graph. And it gets a little messy with all the graphs in there. But there is my cube root graph. Domain and range? Yep, all reals. Okay, hopefully you see those parent functions in place. You guys, the transformations don't change. It doesn't matter what type of graph we're doing. Radical graphs, quadratics, absolute value. We're going to next talk about log functions. It doesn't matter with those. They're going to have the same function transformations. Okay, let's work backwards now. Right now, what I want to do is I want to, given a parent function being the square root of x, I want to write a function that has the following conditions. I want to move it 2 to the right and 1 up. Hit pause and see if you can write an equation using the square root as the parent function that moves 2 to the right and 1 up. Okay, hopefully on this one. If we're moving 2 to the right, I know that what's going to be inside here is going to be negative. So I'm going to have an x minus 2 inside the square root. Then if I move up 1, it's going to be plus 1. 2 to the right, up 1. All right, if you didn't get that one, hit pause and try this next one. This next one says a vertical reflection and up 6. A vertical reflection just means we're flipping it, right? That's just a fancy way of saying flipping it. So if I take my function, which is the square root of x, and I want to flip it, I'm going to have a negative outside of the square root. Now, the fact that I'm going up 6 tells me that's going to be outside of the radical because only left and right goes inside. So we would have f of x equals negative square root of x plus 6. Okay, hopefully you see that graphing radicals is not much different than any of the other graphs we've done. Feel free to rewind and watch this as many times as you need to, or hit pause. Or otherwise, your assignment tonight is a worksheet, and we will see you soon.